The J option pane dialog box is a simple alert box that doesn't prompt the user to input any information. To generate a simple alert box like this, you call the J option pane's show message dialog method, like this. To get the dialog box to look like the example here, we would call it like this. Notice that show message dialog is a class method, right? And so we'll call it using the class name. So J option pane is the class. I'll give my non-black pen, right? That's the class. So this is a class method. It's not a instance method. And of course, we have to make sure that we include the JavaX swing package to use it. Now we're going to talk about how we can use the action event object that we pass into our action performed method in our listener class to distinguish between multiple events. And if the option dialog box lesson seemed a little off place, it's because we're going to use it in the upcoming code. So just stay with me.
So now that we've covered the J option pane dialog box, let's take a look at how we can use the action event object to distinguish between events. So here is the factorial button separate events class, which is much like the factorial button class we've already looked at. The primary difference is when we come here and we look at the action event E, we actually use it here. Right here we say if e.getSource, and getSource is a method of the event. So we're saying if the source of the event being fired is Xbox, which is the box where we type in our initial number, then pop up a message that says, hey, you've got to actually click the button to do the calculation. Otherwise, if it's anything else, then go ahead and do the actual execution of the program. Right? So if we run this, and pick the right one here. All right, so here's our class, right? And so before I could type in 10 and hit enter. Well, now it's telling us that, hey, you've got to actually click the button to perform the calculation. So now if I click the button, it actually calculates what the factorial is. Okay. So one other thing that I want to show you is I also modified this program to actually hold a reference to its parent. And here I added a constructor where I set that equal to whatever's passed in under the constructor. So if we come up here and we look at listener, we pass in a reference to this. Well, this on this line is the factorial button events class, which is a JFrame class. So the parent is a JFrame object. And what that does for us is it allows the pop-up dialog box to be centered on where it is, right? So if I say I run this program again, all right, pick the right one. All right, if I have it up here and I do the calculation and I hit enter, notice how the message pops up right on top of wherever it's at, right? If I pop it up over here, it pops up down there, okay? If we get rid of that option, if we get rid of that parent object, so let's take out this constructor, okay? Actually, we don't even have to take it out. What we'll just do is we will just change this from parent to say null. Okay, that says, you know what? We're not going to specify a frame for you to show in, so we want you to show up just wherever. If we run this program now, oh, got to pick the right one. All right, now if I run it, before when I hit enter, it would pop up on the window. So now it doesn't pop up there. I've got to go over to my other screen, so it's on my primary monitor in the center of the screen, and now I have to drag it over, which is kind of annoying. So that's what this first option does. By specifying the parent, you are telling which window frame you want the dialog box to show up on. And that makes a difference if you've got a program that's spawning multiple frames, multiple windows. You're going to want to be able to specify which one that the alert is tied to. Another thing I wanted to point out is that this event class it's got lots of different methods that are associated with it, right? So it's not just, we've got getSource here, which returns an object, but it has all of these other properties and methods that are associated with it. So there's all kinds of stuff that you can do to it and do with it. It's just a matter of actually using it in your code. Okay, so this is how we can use the event object that we pass in to actually create some more dynamic events within our program.
Most GUI components are comprised of two colors: the foreground color, which is the color of the text, and a background color, which is the area behind the text. So here's how to create a red button with white text. So we declare a button, a new J button with the text click me, and then we call the set background method, and we pass in a constant from the color class, right? And here we also have set foreground color white, so you can see we're setting the background to red, and we're setting the foreground or the font color to white. The set background and set foreground methods are standard mutator methods available to most GUI components. So here's how we get color from a text field object. You can see here that we are getting the, whoops, let me use the right pen. We're getting the background or we're getting the foreground, right? And we're setting that equal to a color object named original foreground or original background. So if you initialize something and you want to keep a reference to what the initial values are set to, this is something that you could do. The color class has quite a few named constants that you can use for predefined colors. To use the color class, make sure that you have the Java AWT package imported. Now, in addition to using the named constants in the color class, we can also create our own colors using the color constructor. Each of the three color constructor arguments is an integer value between 0 and 255, and the int value represents the amount of color, with 0 indicating no color and 255 indicating the maximum amount of color. For example, this statement sets the button's background color to purple. Right? Because we have half red and half blue, right? R, G, B. And so we're going to have a combination of red and blue, which makes purple. Now, also, when you multiply all these values together, you get over 16 million different color combinations, which is more than what the human eye can detect. So this is what we would consider, 16-bit color or true color. To set the background color for a JFrame window, you first have to get the JFrame's content pane. So this is a little bit more work than just setting the color of a button. And then once you get the content pane, you then apply the background color to the content pane. So to get the content pane, you call the JFrame class's getContentPane method. For example, this code sets the background color to yellow. So you can see here we're getting the content pane and we're setting the background color to yellow. Pretty self-explanatory, but you have to remember that this inner part is the content pane of the JFrame. Okay?
So let's take a look at these color things being used. So here we have our class that extends the JFrame, and we set our height and width, and we have two buttons, gray button and blue button. And then here's the usual setup or initialization part of the constructor, right? We're setting the title and the width and all that stuff. You've seen that before. And then we're creating a red button, and we're setting the background color to red. And the blue button, we are setting the background color to some shade of something, right? And then we're adding our action listeners to it. So here you can see that we are, if the source of the event being fired is the gray button, then we're going to set the background color to red. Otherwise, we're setting the background color to blue. All right, so let's go ahead and run this and take a look. So here you see the two buttons. One's red and one's blue. Red and blue. And that's it. Now, why the author chose to have a gray button and a blue button, I don't entirely know. It's the fact to show you that, the button names don't have to necessarily be what they are. So we have a gray button, but then we're actually setting the background color to red, right? But the thing of it is here is that we're using that event object again to get which button we're actually clicking, and then we are choosing what to do based on that. So if we had 3 buttons, we could chain these as in if-else's or even a switch to say, hey, which thing are we going to do and which button was pressed, right? Okay.
So previously you learned about the most common listener, which was the action listener. And you should use the action listener for events where the user does something to a component, such as clicking a button or pressing enter in a text box. But for mouse dragging events, you'll need a mouse listener. In creating a mouse listener, you use the same basic steps that you use for the action listener. You'll need to define the listener class, define an event handler method, right? And then register the listener class with the component. So it's almost identical to the regular action listener in how you set it up. So here's the API headings and descriptions for some of the more popular mouse listener interface event handlers. We have mouse clicked, which means you are just clicking and releasing. Mouse pressed is the pressing down of the button. And then mouse released is the opposite. It's when you actually release the button. So mouse clicked is the combination of these two. Additionally, here are the API headings and descriptions for the mouse motion listener interface event handlers. Right here we have mouse dragged, which means we clicked and dragged something, and mouse moved just means that the mouse cursor moved on something that is listening for the mouse moving. Just to reiterate, make sure you pay attention to what methods are specified in what interface. In the mouse listener interface, we have the mouse clicked, pressed, and released events. And in the mouse motion listener interface, we have the mouse dragged and the mouse moved events. So you have to know which interface you're implementing to make sure that you're using the right methods associated with it. For each event handling interface with more than one method, Oracle, which was previously Sun, provides an associated class that already implements the interface's methods for you. Those classes are called adapter classes. And the mouse adapter class implements the mouse listener's interface methods. And the mouse motion adapter class implements the mouse motion listener interface methods. Adapter classes don't do much. They simply implement their associated interfaces methods as dummy methods, like this. So the question then becomes, why do we jump through all of these hoops instead of just implementing the mouse listener interface? Well, for convenience. The mouse adapter already implements the interface for you as a convenience, so you just have to extend and override that method. Otherwise, you would have to write empty methods for all of the methods that are specified in the interface, just as the adapter does. So here you can see we have click listener extending the mouse adapter, right? And the mouse adapter implements the mouse listener. Now this is a very basic example because we're only looking at one method, but some adapters have 20, 30 methods that they implement, and if you only need one of those methods, well then you can just extend that adapter class and you're good to go. Otherwise, you'd have to write empty implementations for every single method before the compiler would allow you to use it, right?
So let's look at our final program for this section.